Hello everyone, my name is Aarti Sahu from BSc Chemistry Honors second year. Today I am going to make a audio record for visually impaired students on the topic distribution law. So we are going to start distribution law from the law Nernst distribution law. Nernst distribution law studies the distribution of a solute between two immiscible solvents in contact with each other. When a solute soluble in two immiscible solvents is added to a mixture of these solvents, the concentration of solute in both the solvent layers is different. In other words, the solute distributes itself in both the solvents. For example, when a dilute solution of iodine in water shaken with carbon tetrachloride, the iodine distributes between two immiscible solvents. Iodine is about 86 times more soluble in carbon tetrachloride than water. Due to high solubility, most of the iodine passes in CCl4 layer. In simple words, iodine is distributed between two immiscible solvents, water and carbon tetrachloride. Nernst in 1891 showed that when a solute is added to a mixture of two immiscible liquids, in both of which it dissolves, then it distributes itself between both the liquids in such a way that the ratio of concentrations of the solute in both the liquids remain constant at constant temperature. However, this ratio is constant only when the solute has same molecular state in both the solvents. That is, the solute neither undergoes association nor dissociation in both these solvents. The generalization put forward by Nernst is called Nernst distribution law and is stated as a solute distributes itself between two immiscible solvents in contact with each other in such a way that at equilibrium the ratio of the concentration of the solute in two layers is constant at a given temperature, provided the molecular state of solute is same in both the solvents. If a solute X distributes itself between solvents A and B, the distribution law is written as concentration ratio of X in solvent A by concentration ratio of X in solvent B, which is equal to C1 by C2, which is equal to K. Here K is the constant and is termed as partition coefficient or distribution coefficient. Second topic is factors affecting partition coefficient. First is nature of solute, second nature of liquid pair, third temperature. Nature of solute. For a particular liquid pair, different solutes have different solubility. Hence, the value of partition coefficient will be different for different solutes in a given temperature. Second, nature of liquid pair. A given solute has different partition coefficient in different liquid pairs. Third is temperature. The solubility of a solute in a particular solvent changes with temperature. As the temperature is changed, the solubility of a solute is given liquid pair also changes. Therefore, the partition coefficient also changes with temperature. The change in the value of partition coefficient K for 1 degree rise in temperature is also known as temperature coefficient. However, the value of temperature coefficient is generally small. Third topic is experimental verification of distribution law. Solution of iodine in carbon tetrachloride of different concentration are shaken with water taken in different bottles. These are allowed to stand undisturbed till the two layers separate out. A known volume of CCl4 layer and aqueous layer is pipetted out and titrated against standard sodium triosulfate solution in the concentration of iodine is determined. The following results from the distribution of I2 between CCl4 and water shows the concentration ratio of concentration in each layer. Hence, prove the validity of distribution law. Next topic is condition for validity of distribution law, that is limitations of Nernst distribution law. The distribution law in its simple form, that is K is equals to C1 by C2, does not hold under all the conditions. Some limitations and conditions undertake which the law applicable are as follows. First, temperature should be kept constant. The solubility of a solvent in both the liquid changes with temperature. This may result in the concentrate this may result in Our next topic is conditions for validity of distribution law, that is limitations of null distribution law. The distribution law in its simple form, that is K is equals to C1 by C2, does not hold under all conditions. Some limitations and the conditions under which the law is applicable are as follows. First, temperature should be kept constant. The solubility of a solute in both the liquid changes with the change in temperature. This may result in change in concentration of both the solvents. Moreover, change in temperature may affect the mutual solubility of two solvents. Therefore, with change in temperature, a different value of partition coefficient is obtained at every temperature. Hence, the temperature should be kept constant throughout the determination of partition coefficient. Second, the two solvents should be immiscible and sparingly soluble. Third, the mutual solubility of the two solvents should not be affected by the addition of the solvents. Fourth, the solution should be dilute. Distribution law holds good for dilute solution. As the concentration of solute increases, the deviation from distribution law become more and more pronounced. Fifth, the molecular state of solute should be same in both the solvents. This law is not valid under following two conditions. First, when the solute undergoes association. The law, in simple form, is not applicable when the solute undergoes association in any of the solvents. For example, distribution law does not hold for phenol distributed between benzene and water because phenol undergoes association in benzene to form dimers. Second, when the solute undergoes dissociation. The distribution law is also not valid for solutes which undergo dissociation in any of the solvents. For example, electrolytes like HCl undergoes dissociation in water and hence its solution in a mixture of water and organic solvent like benzene CCl4 CS2 does not obey distribution law in its simple form. Thank you.